Hello everyone, you are watching my YouTube channel Chemistry by Saad and today we are going to discuss one of the challenging past paper question. The question is in front of you. The rate of reaction between solution A and B is investigated. The data is given here, but we have to do with this data. We have to find the order of reaction. And this is a 2 marks question, but it's a bit challenging. Order with respect to A second, order with respect to B 0. But how one can prove this? Why order with respect to A second? We're gonna mathematically prove this. We're gonna learn this. Guys, here you see the concentration of B is constant in experiment number 2 and 3. So if I choose experiment number 2 and 3 to find the order of a reaction with respect to A, why I am going to choose experiment number 2 and 3? Because in experiment number 2 and 3, the initial concentration of B is same and initial concentration of A is changing. So I am going to choose this. So a rate, initial rate, I'm going to write just rate of experiment number 3 is equals to rate constant and concentration of reactant A in experiment number 3. So divided by rate of experiment number 2, I am going to find how much rate is changing, how much this rate is changing and how much concentration is changing. Rate constant K, initial concentration of A of experiment number 2. So rate is 8.10 into 10 raised to power minus 4. For experiment number 2, the rate is 3.60 into 10 raised to power minus 4. K will be constant. For A3, this is 5.40 into 10 raised to power minus 3. I'm going to write solve here because data is available here, data is given here. For A2, 3.60 into 10 raised to power minus 3. And here I will put small m that represent order. I will put small m is for the entire situation, small m represent order. So this will be cancelled out, A will be cancelled out, this will be cancelled out. What left behind is 8.10 divided by 3.60. So when I divide 8.10 by 3.60, I will be getting 2.25. And here 5.40 divided by 3.60, I will be getting 1.5 raised to power m. Now I have to find m, which represent order with respect to A. So what I do, I apply mathematics, apply natural log on both sides. So when we apply natural log, the power will be shifted here, m natural log 1.5. So natural log 2.25, when I bring this natural log to other side, it will be written like this is equals to m. So guys, when you use your calculator and you will solve this, you will get 2. So it means m is equals to 2. So we can say with respect to A, order is second. This is proved. Now we are going to find order of reaction with respect to B. You can note down this. I'm going to erase it. With respect to B, order is 0, but how? There is different ways to prove this. One thing which I want to share with you guys is you can see in the given data and concentration, this is same as we have chosen experiment number 2 and 3, and this is same. Like A is changing, but B remain constant. A is changing, but B remain constant. So as B remain constant, so we can say the reaction does not appear, does not depend on B. It means reaction is 0 order with respect to B because concentration of A is changing, but concentration of B is not changing. So reaction is 0 order with respect to B. But guys, if you want me to prove this mathematically, It can be a bit challenging for me, but I will try. Okay, let's see. You can ask me why I cannot choose one and two. Here concentration of B is changing. So if you want this, we can do this. Now I am going to choose these to experiment. And you now order with respect to A is second. So here I'm better for me to write here. Now rate for experiment number two, because I'm going to choose one and two. Rate of experiment number one is equals to rate constant K will be cancelled out, so I will not write down that. Initial concentration of reactant A of experiment number two, initial concentration of reactant A of experiment number one, and you know its order is two. So I'm gonna put two here. Similarly, initial concentration of B of experiment number two, initial concentration of B of experiment number one. Its order I do not know, so I'm gonna put small n. Rate is 3.60 into 10 raised to power minus 4, 1.60 into 10 raised to power minus 4. A2, you know this concentration is 3.60 into 10 raised to power minus 3, 2.40 into 10 raised to power minus 3, and power is 2. Here 4.20 into 10 raised to power minus 3, 2.80 into 10 raised to power minus 3 raised to power n. I don't know n. I have to find out that n. So this will I'm going to cancel out like that. And 3 points this will be when you solve this. When you solve this, 1.5 raised to power 2. When you solve this, 1.5 raised to power n. I am going to put here 2.25 is equals to 1.5 raised to power 2 into 1.5 raised to power small n. That small n represent order with respect to reactant B. So make it simplify this. So divide this 2.2.5 5 here. Similarly, one thing which I need to do is when you take 1.5 square, this will be equals to 2.25. So 2.25 is equals to 2.25. I can write like that times 1.5 raised to power n. Just make it simplify. Bring 2.25 other 5. Sorry, what I'm saying. Take 2.25 to other side. We are just simplifying. This will be cancel out. Here you just get 1.5 raised to power n. Apply log, natural log 1 is equals to when you apply log, n will be here, and natural log 1.5. So natural log 1 divided by natural log 1.5 is equals to small n. So guys, when you put this at calculator and when you solve this, you will get 0. N is 0. So it means zero order with respect to B. So guys, this is how I solve this question. I also offer one-on-one customized individual lessons in which I will address your queries. I will solve past paper question with you. So guys, you can contact me for one-on-one tutoring session. Please don't hesitate. You can contact me. Thank you so much for watching. I do request to share this video with your class fellows. Thank you so much for watching. Have a nice day. Enjoy.